So let's start the session. Good evening. Welcome to this week 12 of the live interaction session for the course Multimodal Urban Transportation Systems. The instructor is Professor Orkopal Goswami from IIT Kharagpur and I am Shankadeep Pramanik from IIT Kharagpur. So this is the last week of this course where we discuss about different safety aspects as well as some environmental concerns related to urban transportation. We started with defining that how safety and security are important and how they what they actually means and how they are different from each other. Then we discussed about different risk factor associated with traffic injury, like speed is one of the major risk factor. Because of the speed, the severity of the injury changes from a fatal to non-fatal, and there are also other risk factor like alcohol, drunken driving, or related to different pedestrian infrastructure or pedestrian visibility of the pedestrian at the intersection. These things are also one of some of the risk factor that we have discussed. And we also discussed about different roadway design and land use planning factors like traffic mix or pedestrian crossings or high volume roads. These things were discussed. Then we discussed about different predictive methods, and where we discussed about different how different terminologies like which are how we should analyze the data, and different prediction like crash frequency or crash rate. These terminologies are discussed. Then we discussed about different parameters of crash predictive methods. uh, After that, we discussed about predicting vehicle pedestrian or bicycle conflicts, and different accident modification factor, how they are calculated. These things were also discussed. Also different environmental concerns, uh, like mm, related to pollutions and noise pollutions. These things were discussed. Lastly, potential mitigation options and their impacts and potential mitigation options, that was also discussed. So with that, we concluded this week and this course. So now moving to the question answers. First is, providing a buffer comes under which section of pedestrian safety enhancing interventions? Reducing vehicular speed, improving the visibility of pedestrian, reducing pedestrian exposure to vehicular traffic, or providing care for injured pedestrian. So providing a buffer comes under which of the section of pedestrian safety? Right, C will be the answer. It reducing the pedestrian exposure to vehicular traffic. So pedestrians are vulnerable and to the mainly to the speed of the vehicle. So if we can segregate the pedestrian with some space or some with some furniture, then the impact of the crash can be reduced. So providing a buffer is one of the solution to reducing the pedestrian exposure to vehicular traffic. So in that case, a area which may be parking or which may be by different guardrails or using other measures, we can segregate the pedestrians from the high speed vehicular traffic, or pedestrian facility. We can provide some pedestrian facilities to segregate the pedestrians from the main vehicular traffic. These will act as a buffer. Next is a 3-mile section of road that has 16 crash over 4 years and has a traffic volume of 5,000 vehicles per day. What is the crash frequency? Sixteen crash over 4 years. It will be in terms of crash per year. So these 3-mile or 5,000 vehicles per day, these data are not required to calculate this crash frequency. Crash frequency is the number of crashes and period in years. So here 16 crashes occur over 4 years. So 16 by 4, it will be 4 crash per year. Option C. Then a driver in a car on a residential street is traveling at 45 km per hour. He puts on the brakes when he sees a stop sign. The coefficient of friction between the tires and the road mu is 0.5. Given G is 9.8 meter per second square. What is the stopping side distance of the car? So velocity is given 45 kmph. But in the answer all the units are in meter, so you can convert it to meter per hour. Here don't consider here the reaction time of the driver, only the distance that is required to stop the car. That is, you need to calculate D, which is V square by 2 mu G. A is the correct answer. So given V is 45 km per hour, and if we convert it to meter by dividing it by 3.6, so it will come as 12.5 meter per second. Now stopping side distance formula is D equal to V square by 2 mu G. V is given as 12.5, mu value is 0.5 and G value is 9.8. So if we calculate it, the stopping side distance of the car will be 15.9 meter. Option A. Next is calculate the total CO emissions generated along a 40-kilometer road from a mixed traffic consisting of 10 trucks, 16 cars, 20 two-wheelers. The E value of the CO for truck, car and two-wheeler are given, and you have to calculate the total CO emission generated along a 40-kilometer road from these traffic compositions. These are the emissions compound for a particular for CO for car or two-wheeler or truck, and the number of trucks and car all are given. Is it coming 5.2? Okay. Did you use this formula? Right, it will be 2.84, not 5.2. So we can use this formula to calculate the vehicular emission, where emission of a particular component is the number of vehicle per type. There are three types of vehicles: truck, car and two-wheeler. Then distance traveled per different types of vehicle, like distance traveled is for 40 kilometer and emission of compound from a particular vehicle type. So these values are given, emission given. So total emission for CO will be multiplication of this for truck it will be 4 is 4, number of truck is 10 and 40 kilometer is the length. So this one is for truck, then this one is for car, number of car is 16 and emission is 1 gram per kilometer, and this one for two wheeler it number of two wheeler is 20 and emission is 0.75 gram per kilometer. So if we add it, it will come as 2.84. Option C. Next is pedestrian security measured through incidents of crimes in an area, number of pedestrians killed or injured in collision with motor vehicle, both through A and B, or none. C will not be the answer, it will be A, because here it is saying pedestrian security, and security and safety are two different things. So security is mainly related to crimes and uh, more related to these crimes and all, so violent crimes. So this is but safety is related to collision or collision with vehicles and how they are safe from the vehicular point of view. But security is theft, assault, this kind of things also comes under security. So to increase the security you can maybe provide CCTV camera or adequate police personnel, but for safety, for enhancing the safety, different facilities like traffic calming strategies or education programs, these things are required. So in this case it is asking for pedestrian security, so number of incidents of crimes in the area will be the correct answer, and a second is number of pedestrian killed or injured in collision with motor vehicle. So it is more related to safety, not security. Option A will be the correct answer. Next is find the entropy index for the following land use distribution. This is the land use distribution and you need to calculate the entropy index. So this is the entropy index formula, and you need to first calculate this pi from for a particular land use, which will be total divided by this count. Then you need to apply this formula. Right, D will be the correct answer. So this table is given, and this is the formula for calculating the entropy index. So now for each type of land use, we have to calculate first the P, which is this total is 49, and for each one the count divided by the total will be share of that land use. So there are four types of land use, so total J will be equal to 4. Now if we put these values in the formula, so uh, for the water it will be 0.31, and logarithmic of 0.31 will be minus 1.17, and similarly for agricultural, residential or industrial, we have to put the corresponding values of 0.31 or 0.16 or 0.22, and in the denominator logarithmic of j, which is 4, will come as 1.386. Now solving this, it will come as 0.97. The entropy value ranges between 0 to 1, minus 1 to 1, minus 1 to 0, none of the above. Well, it is 0 to 1. Accept or reject statement. The number of crashes occurring in a particular site in a year is crash rate. the statement will be rejected because whenever we say crash rate, it is basically the number of crashes that occur at a given site during a certain time period in relation to particular measure of exposure. Means how many vehicles are moving in that stretch, with relation to that the uh, this frequency of crash will be considered. So that will be crash rate. So exposure is also considered in case of crash rate, not only the number of crash and the time period. So that's why this statement will be rejected. Here only the number of crash that occurring in a particular site in a year. So only two things were considered. So it is basically crash frequency they are telling, but for crash rate it will the exposure of uh, mm, exposure needs to also account. Next is, which of these parameters help in determining vehicular technology, determining vehicular emission, fuel quality, road and traffic management, all the above. So all these options are correct. Vehicle technology like BS1, BS2, then fuel quality also depends, and road and traffic management is also one of the factor for determining vehicular emission. And also their speed will also sometimes contribute to this vehicular emission. So all these options are correct here. Next, which of these should emit least emission? The BS stands for Bharat Standard, and these are used in different Bharat stage, and these are used for defining the pollution level of vehicles. And in the very early stage, we used to use Bharat stage 1 or 2 and 3 like that, but now the vehicles which are in the market are more are from mainly Bharat stage 6 or uh, BS4. Then and the emission, actually these standards are selected based on the emission, and the emission is reducing as we go higher stage. So in earlier days the emission was quite high, but in latest models of car which are BS6 or BS4, emission so these actually the pollution actually uh, reduces in this BS6 or this BS4 compared to BS2 standards. So BS6 will should emit least emission, although sometimes it depending on the situation, but the for the engine, if it is BS6, then it should emit least emission. Next, moves is which type of, okay, it is even already macroscopic. So there are different emission models. Emit, where is the word? Oh, emit means like it is short from emission. Which of these should mm, what can I say, like it will mm, mm, what can I say, it will emit least emission. So like the it will create or um, like produce or discharge actually. In this case you can say it will discharge least emission. So next is find the accident modification factor for angled on-street parking that is present along a four-lane undivided arterial road in a commercial area. The sum of the total curb length where parking is available is 4 miles, while the total length of roadway segment is 9 miles. Use the following table to reach the correct answer. This one, find the accident modification factor. So the formula for accident modification factor is 1 plus pk into fk minus 1, where this we have to calculate this pk, which is the proportion of curb length with on-street parking. So uh, parking is available in 4 miles, while the total length of the roadway segment is 9 miles. So out of 9 miles, 4 mile parking is available. So this pk will be 0.44. Now this fk value we have to calculate this we have to get this factor from this table, and the parking is angled on street parking in a four lane undivided arterial road in a commercial area. So it is a angled parking, commercial area, and four lane undivided road type. So the factor will be 3.99. So AMF will be 1 into 0.44 that we have calculated, and FK value is 3.999 minus 1. So 2.32 will be the correct answer here. Next, the following graph shows the change in emission factor of which, okay, it is also written here. It is there are two graphs we have discussed. One is CO for CO and one is for NOx, and the curves are different, and these two for vehicular emission factors. Next is find the a bicycle crash frequency for a 4-lane undivided arterial where posted speed limit is 30 meter per hour, having a predicted average crash frequency of 4.62 without pedestrian and bicyclist. Use the table to reach the correct answer, this one. So you have to calculate the bicycle crash frequency for a 4-lane undivided arterial road. So pedestrian or bicycle for pedestrian or bicycle case for predicting the crash per year, this is the formula where we have uh, this predicted NBR is the predicted average crash frequency of a individual roadway of a segment, and that is given as 4.62. So the this average crash frequency value is given and multiplied by a factor. The factor we can get from this table for this 4-lane undivided arterial road. So 4-lane undivided arterial road where posted speed limit is 30 meter per hour. So posted speed limit is 30 meter per hour. It will, the factor will be the adjustment factor will be 0.011. so if we just multiply these two, then we can get the predicted average pedestrian crash, and it will come as 0.51. so option B will be the correct answer. Next, EIA, environmental impact assessment for transportation project, is least effective when conducted at which stage? So there are 4 stages: pre-construction, construction, operation, post-construction. And the least effective when it is conducted in post construction stage. So it is better to do the environmental impact assessment as early as possible, preferably before the construction, or even if it is not possible to conduct the EIA before construction, then at least in construction or in operation stage it must be conducted for getting the major benefit. Next is, arrange the following in correct order with respect to EIA: screening and scoping, mitigating impacts, impact assessment, and establishing the baseline. So there are different steps involved while conducting the EIA. First step is screening and scoping, and then we establish the baseline. Then actually the impact of a proposed construction or proposed anything proposed policy, the impact of that is assessed. Then the next step is to mitigate these impacts, and monitoring and evaluation is also there. So based on that, the the arrangement will be first screening, so 1, then establishing the baseline for impact assessment and mitigation impact. So option D is the correct answer. Then ambient noise standard for residential area at night is, so it is for residential area the ambient noise at night time is 45. Option C. Next, a 3-mile section of road has witnessed 15 crash over 4 years and has a traffic volume of 12,000 vehicles per day. What is the crash rate in terms of 100 million vehicles miles traveled? This uh, formula you can use. It is n is the ER, this L is the length, this C is crash, and V is number of vehicles. So there are 15 crash uh, over the 4 years and in 3 miles section. So 3-mile section 15 crash 4 year and the traffic volume is 12,000. The traffic volume is 12,000. So if we just put the values, then it is actually 28.54 crash per 100 million vehicles traveled. So option A is the correct answer. An ASI approach, which of the following is related to vehicle efficiency? So ASI stands for avoid, shift or improve approach. So it will this I stands for this improve. So that's all for this week. If you have any doubt, then you can ask. Also, there will be a doubt clearing session in the next Monday. If you have any doubt, then you can also uh, ask there if you find any doubt in any of the week. Otherwise, you are free to leave also.